Okay, today we're going to talk about solving absolute value equations, and we're going to learn to do it algebraically. So we're going to learn how to solve absolute value equations, and we're going to talk about extraneous roots. So whenever you solve an absolute value equations, you have to get what is in the absolute value symbols alone. You have to write two equations, and then you have to solve both. So what we're going to do is we are going to add 3 to both sides. So that's going to give us the absolute value of 2a equals 8. And we're treating the whole absolute value equation like it's an x or any kind of variable or the whole part. So this is multiplication. So to undo multiplication, we're going to divide. So now I'm going to get the absolute value of a is 4. And from there, you just write your two equations. A equals 4. And when I say the second one, you're going to make this constant right here, you're going to make it a negative 4. So those are my solutions. A is equal to positive or negative 4. Same process here. Since these absolute value symbols are already alone, I'm going to write my two equations. 2x minus 3 equals 11. And 2x minus 3 equals negative 11. You're going to add 3 to both sides in the first equation, and you're going to get 2x equals 14. If you divide by 2, you get x equals 7. Here, if we add 3 to both sides, we're going to get 2x equals 8, negative 8. And if I divide by 2, x equals negative 4. Now, if you were to check both of these solutions, you would see that it works. So 2 times 7 minus 3 is 14 minus 3, the absolute value of that, and the absolute value of 11 is 11, so that checks. If you're going to check the second one, the absolute value of 2 times negative 4 minus 3, okay, so 2 times negative 4 is negative 8. Negative 8 minus 3 is negative 11, and the absolute value of that is positive 11. So you can see that both of those solutions work. Let's try another example. Okay, one thing that I want to make clear is you do not distribute. Okay, do not distribute. Okay, treat that as negative 3 times that whole thing. So it's like solving negative 3x equals 9. And we would divide both sides by negative 3. And when we do this, we're going to get the absolute value of 2x minus 1 equals negative 3. Now, by definition, absolute value will never, ever be negative. So whatever value of x is, this whole thing has to become a positive number. A positive number will never, ever equal a negative number. So that means that there is no solution to this absolute value equation. All right, so now sometimes when you solve equations in Algebra 2, you get this extraneous root. An extraneous root is a solution found. So you solve the equation, you find a solution, and you go to check it, and it doesn't work. And it usually works in algebra when our variables are on both sides, at least in absolute values. So we've got our variables on both sides. So we're going to go ahead. We have the absolute value symbols alone, and we're going to write our two equations. 5x minus 12, 2, the absolute value of that, equals 7x plus 14. And then the absolute value of 5x minus 2 equals negative. We're going to negate the whole thing. So you got to distribute that negative. So it's the absolute value of 5x minus 2 equals negative 7x minus 14. So let's just solve that equation first. Get rid of the absolute value symbols. I don't know why I wrote them in there. So I'm going to add 7x to both sides. And I'm going to get 12x minus 2 equals negative 14. If I add 2 to both sides, I'm going to get 12x equals 12. And if I divide by 12, x equals 1. Should be negative 12. X equals negative 1. Sorry, you guys know me. I can do calculus, but not general math, basic math. Can't balance a checkbook. All right, so now here, if I subtract 7x from both sides, I'm going to get negative 2x minus 2 equals 14. If I add 2, I'm going to get negative 2x equals 16. If I divide by negative 2, x equals negative 8. All right, so now if I substitute in, I'm going to get the absolute value of 5 times negative 8 minus 2 equals 7 times negative 8 plus 14. And I'm guessing that this is not going to be a solution. The reason is, if I multiply this, I'm going to get negative 56 plus 14, and that's going to give me negative 42. Well, remember we said that this whole thing right here has to be positive, and it has to be positive, but it's so it wouldn't equal negative 42. So this is not going to be your solution. Okay, let's check negative 1. The absolute value of 5 times negative 1 minus 2 equals 7 times negative 1 plus 14. So negative 5 minus 2, the absolute value of that is positive 7. I get an absolute value of negative 7, jump the gun. And then negative 7 plus 14 is 7. So our solution is just negative 1. When we go to look for extraneous roots, we can have one solution, no solution, or we can have two solutions. Let's look at one more example. So when I rewrite, remember I'm going to negate this whole thing here. So I get negative 2x plus 9 equals 3x plus 10, and negative 2x plus 9 equals negative 3x minus 10. So I just distributed the negative. Right, so in the first equation, if I add 3x to both sides, I get negative 5x plus 9 equals 10. If I subtract 1 from both sides, I'm going to get negative 5x. Sorry, I'm thinking ahead. Subtract 9, I'm going to get 5x equals 1. And if I divide by 5, negative 5x equals negative 1/5. Okay. In my second equation, if I add 3x to both sides, I'm going to get x plus 9 equals negative 10. If I subtract 9 from both sides, I'm going to get x equals negative 19. So again, I'm going to start, I always start with this side when I check, because I know if I get a negative number, I'm done. So if I put in my negative 19, 3 times negative 19 plus 10 is definitely going to be a negative number, because 3 times negative 19 is going to be negative 57 plus 10, and that's negative 47. So we know that's not a solution. If I put in 1/5 negative, I'm going to get a positive number, so this might not be as fun, because I got to deal with the fractions. But if you get the absolute value of negative 2 times 1/5 plus 9, so I get 2/5 plus 9, the absolute value of that. 9 is 45/5, so I get 47/5. And then if I put in, and it was the absolute value of that, which is positive. So now if I put it into the other side, 3 times negative 1/5 plus 10 is negative 3/5 plus 10. For those of you that didn't quite get what I did last time, we want this over fifths. So I have to multiply the 10 by 5 and I get 50. Negative 3 plus 50 is positive 47/5. So these are equal, so our solution is negative 1/5. So today you looked at how do you solve absolute value equations. Remember, we're going to get what's in the absolute value symbol alone. We're going to write two equations with the constant, side with the constant, or the side opposite the absolute value symbols negated. We're going to solve both. When you got variables on both sides, you need to check for extraneous solutions or solutions that don't work. Have a math-tastic day.